Maupay nga adlaw sa iyong atanan, class. Welcome back to my channel. So our topic for today for integral calculus. This is the first topic for our Unit 2, Techniques of Integration. So the first technique that we're going to evaluate and discuss, integration by parts. So integration by parts. So let's consider the differential of a product of two functions u and v. So the differential of a product u and v is equal to u dv plus v du. Now if we're going to integrate the function uv, we get integral of u dv plus v du. So to rearrange this formula, this equation, we can have the integral of your u dv is equal to u v minus integral of v du. Now this is our we call this IBP number 18. So this is our number 18 formula in integral calculus. IBP stand for integration by parts formula number 18. So IBP 18 formula is specifically applicable to ATEL. What's ATEL? ATEL stand for algebraic, trigonometric, exponential, and logarithmic function. So if we're going to evaluate certain functions, it's a combination of two. It's either a combination of algebraic and trigonometric, or algebraic and exponential, or it's a combination of algebraic and logarithmic. Logarithmic n. So ATEL. Or it's a combination also of your trigonometric and exponential, and trigonometric or logarithmic. So if you can see certain function, you need to identify, or it's either a combination of two algebraic function, two trigonometric, exponential, and logarithmic. Always you're going to use integration by parts if the function is a combination of algebraic, trigonometric, exponential, and logarithmic, or a combination of two of each function type. Okay, so I hope it's clear. So let's proceed to our first example. Our first example number 1, evaluate the integral of z a raised to z dz. So it's a combination, this function is a combination of two, our algebraic and exponential. Algebraic. Okay, so let's assume value for your u and dv to be aligned. So our IBP integration by part formula number 18 is integral of u dv is equal to u v minus integral of v du. Now we need to align our function first here. So we need to identify what is our u and what is our dv. So we'll start with our u. So we let u equal, this is our u and this is our dv. So we let our u equal to z. What process we're going to do with u? We differentiate u. dv, we integrate dv. Okay, so what is the differential? First derivative of your u equal to z. So that is your du is equal to derivative z, dz. Okay, how about for your dv? So we let dv equal to a z dz. If we're going to integrate a raised to z, it's a constant, so our v is still the same, a z plus c. So just integration. Then we rewrite our function according to alignment of RBP formula number 18. Okay, so what is our u? So that is your z. What is your v? That is your a raised to z minus integral of v a z. Then your du is your dz. Okay, so apply integration. So in this side, here we simplify z a z. If we apply our integration, it would be still the same, a z plus c. So that is your final answer for your example number 1. So to identify again, this is our u, this is our v, the same. So this is our v and this is our du. Okay, so they are all in alignment. So let's proceed to next example. Our next example is evaluate the integral y squared sine y dy. Okay, so we need to identify our u. We need to identify our u. So in this case, we're going to use our algebraic as our u. In trigonometric as your sine y dv. So this is your dv, this is your u. Okay, so start with our u. Let's recall our IBP number 18. Integral of u dv is equal to uv minus integral of v du. Okay, so we let our u equal to y cube. So first derivative of your u, that is 3y squared dy. Next is for your dv. So your sine y dy, your v is the integral of your sine y, that is your negative cosine y plus c. So now we follow the formula IBP 18. So we rewrite our function according to alignment to our formula. So first our u, y cube, our v, negative cosine y minus integral of our negative cosine y, and your du, that is 3y squared dy. Okay, so we simplify negative y cubed cosine y. Here we carry out our constant and we apply our negative sign to become positive. So positive, negative times negative, so positive. So we carry out property number 2, our real number constant. So carry out 3, integral. Then we rewrite our function. So the remaining is y squared cosine y dy. Here, if we're going to apply our integration parts again, okay? So notice that our power is 3, a power of 3. So we need to apply integration by part 3 times. So we have 1. So we still need to apply since our function at this side is not yet stable. Okay, so we let u again here. We let u equal to y squared. So our du is 2y dy. Then for our dv, that is your the remaining cosine y dy. So your v is your sine y plus c. Again, we rewrite according to our formula number 18. But we carry down this term and we apply our integration by parts in this part, in this second term. Okay, so 3. Okay, so we apply integration by parts. So what is our u? U is your y squared your v is sine y minus integral of your v again, sine y, then your du, that is 2y dy. We apply our 3 since it's outside the bracket. So if we're going to apply our 3, going back inside, so that is 3y squared sine y minus 3. Oops, we have real number constant again. 2 integral of y sine y dy. Okay, we are okay in our second term. So we still need to again integrate this. So this is our second integration by parts. So we still need to apply since we need 3 integration. So let's simplify first our last term. So 6 integral of y sine y dy. So again, we let our u at this side. So here, of course, it's still the, so here naman, we apply our integration by parts again. We let our u equal to y. So our du is equal to dy. About for our dv, so that is sine y dy. So our v is negative cosine y plus c. So again, we apply our integration by parts. Negative 6 bracket. So our v, our u, that is your y, our v is negative cosine y minus integral of your v, negative cosine y, and your dy is your du is your dy. Okay. 6 rationalize. So that is negative times negative, that is positive. 6y cosine y. How about here? So let's start here first. Negative times negative, positive times negative, still negative. So we apply 6 integral of cosine y dy. In this part, it's only one term, cosine y dy na lang. So we can directly integrate this part. So if we integrate, that would be 6 sine y plus c. So we bring down all the term. So our term should be 4 greater than 3. So our final answer for this example, negative y cubed cosine y plus we carry down 3y squared sine y plus 6y 6y cosine y minus 6 sine y plus c. So this is your final answer for your example number 2. Okay, let's proceed to example number 3. So example number 3, evaluate the integral of x ln x dx. So this is a combination of algebraic and logarithmic, ln x dx. So we recall our IBP formula, integration by parts, number 18 formula. That is integral of u dv u v minus v du. So let's make it clear. So that is your u v minus v du. Okay, so this part we identify our u, that is your ln x, then our dv, that is your x dx. Okay, so we let our u equal to ln x. So if we're going to get the derivative of your u, so that is your 1 over x dx. How about for your dv? That is your x dx. If you're going to integrate, apply power formula, that would be 1/2 x squared plus c. Now we follow our formula. We rewrite according to our formula. So what is our u? Ln x. What is our v? 1/2 x squared plus c minus integral of what is your v? 1/2 x squared. What is your du? That is 1x dx. Okay, so we simplify. So we carry out 1/2 x squared ln x. Then we carry out real number constant. So 1/2 integral of x squared 1x dx. So we cancel out some common terms. So x power. So that is 1/2 integral of your x dx. So if we apply power formula in this second term, finally we can have our final answer. Your final answer is 1/2 x squared ln x minus 1/2, apply power formula, that is 1/2 x squared plus c. So finally, 1 half x squared ln x minus fraction 1/4 x squared plus c. So this is your final answer for your example number 3. Okay, let's proceed to our example number 4. Example number 4, integral of x cubed x squared plus 16 1/3 dx. So it's obvious that it's a combination of two algebraic functions. So we need to rewrite this first. So we break x cubed to x squared. So x squared, quantity x squared plus 16 1/3. We cannot expand the second function, x squared plus 16, since its power is fraction 1/3. So it's kind of difficult thing to do if we're going to expand this using the power is fraction. So we break x cubed to 2. So that is x dx. Now, can identify our u. Our u is x squared. In our dv is your second term, x squared 16 raised to 1/3 x dx. So let's recall our IBP formula. IBP, integration by part, number 18, integral of u dv uv minus v du. Okay, let's start with our first term. So we let u equal to x squared. So if we get our du, that is 2x dx. So for our dv, dv, that is x squared plus 16 1/3 x dx. Here, we can determine our correction factor to integrate this function. Okay, so here we use our we identify our x squared 16 plus equal to u. So we let x squared plus 16 as our u, since we have a power fraction. So first derivative of your u, that would be 2x. So your dx is equal to 1 of first derivative of your du. So your dx is equal to 1 over 2x du. Now we can apply to our second term. So we replace x squared plus 16 equal to u 1/3 x. What is our correction factor? Dx. That would be 1 over 2x du. Now we cancel. We apply some cancellation. So we cancel x. The remaining is 1 half u raised to 1/3 du. Here, we can what shall we do with this part? We already determine. Okay, but we need to apply this one. So our dv, finally, our dv, if we're going to integrate this part, so our v, we need to integrate this 1 half u 1/3 du. So the resulting here, so you have a real number constant, you carry out outside the integrand. So applying our power formula at u raised to 1/3, the final answer of this integration of this function would be 3/8. We recall our value for our u, x squared plus 16 4/3 plus c. So we have our v. We have a u du, we have dv our u. Now we can use our formula. Okay, going back. So what is your u? U is x squared. V, that is your 3/8 quantity x squared 16 raised to 4 third minus integral of your 3 8 x squared plus 16 4 third, then your du, that is 2x dx. Okay, we can still use our correction factor here. Observe. So at this side, this is okay. We just need to simplify. So 3 8 x squared plus 16 4 third. Here, we carry out the real number constant. So we have 3 8 integral of x squared 16 4 third. Sir, why didn't you take the 2 as your constant? So, because we need to apply our dx here. So, if we have 2x, then we apply our correction factor, our dx. We only eliminate the term. So, the resulting would be 3 8 integral of x squared plus 16 4 third. Okay. Then we replace our x squared with u to make it easier to solve this term, the second term. So we replace x squared by our u raised to 4th term du. So it's a line. So in this side, we just carry down this first term. So we apply our power formula here. So 3 8 u 4 third plus 1 over 4 third plus 1 plus c. So that is 3 8 u 7 third plus c. So 3 8 3 over 7 u 7 third plus c. So finally we can say the negative 3 7 and 9 56, then our u, that is 7 third plus c. So carry down our first term, that is 3 8 x squared quantity x squared plus 16 raised to 4 third. So this is your final answer. For final answer, we need to recall our u. Recall u. You rewrite u as your x squared plus 16. Just input the value of u and that is your final answer. Okay? So let's move to our next sample. Example number 5. Evaluate x cosine x dx. So we recall our formula IBP, integration by part number 18. Integral of u dv is equal to uv minus v du. So this is a combination of algebraic and trigonometric. So we identify our u and x, and for your dv cosine x dx. So we let u equal to x. So what is your du? That is dx. How about for your dv? That is cosine x dx. So your v is your equal only to equal to sine x plus c. Okay, so we rewrite our function according to our derivation or derivative and integration. Differentiation here, integration here. So we rewrite according to our IBP 18, integration by parts formula number 18. So what is your U? U is your X. What is your V? That is sine X minus integral of your V, sine X. And your du is your dx. All in the same equation. So we simplify. So that is sine x minus the integral of sine x, that is negative cosine x plus c. So finally, our final answer, x sine x, negative times negative, positive cosine x plus c. So this is your final answer for example number 5. So last problem, example number 6. Evaluate the integral of 3t a raised to 2t dt. Okay, let's recall our IBP 18. Integral of u dv uv v du. So identifying, so this is a combination of trigonometric and exponential. So for our u, this is our dv. So we let u equal to 3t. So your du is 3. About for your dv, that's equal to a 2t dt. So since it's a constant, we only apply to power. So this is 1 half a 2t. So we follow the formal arrangement of our term according to IBP 18, integration by parts formula number 18. Okay, so what is your u? Again, u is 3t. Your v is 1 half a raised to t minus integral of v, that is 1 half a 2t. What your du? That is your 3 du dt. So this is 3 dt. Okay, so simplify. 3 times 1 half, that would be 3 halves t a to t. So we carry out real number constant. So that would be 1 half and 3. That would be 3 halves. Integral of e to t dt. Now we can apply our integration here. So 3 halves, if we apply our integration, that would be 1 half e to t plus c. Okay, so your final answer is 3 halves t a to t fraction 3 halves times 1 half, that would be 3 4 a to t raised to t plus c. So that is your final answer for your example number 6. Okay, for your exercises, you can access your Moodle account and submit your solution and answer in your Moodle account. Exercise number 6, topic integration by parts. So if you have comments, comment down below, so comment section in our video. If you have other question, you can send message to our GC. I think that would be all for today. So thank you everyone, and God bless, and have a nice day everyone. Thank you.